Previously on Days of Steel, TK and Maria meet up at their reunion with significant others. While everyone is excited for free drinks, food, and music, TK and Maria are more excited to do trust calculations. And for good reason. As engineers, they prioritize safety first. So far, they've checked yielding, fracture, and block shear. Now they are ready to check bolt limit states. And oh yeah, check up on their significant others too.
Let's see what the bolt limit states gives us. I am assuming the force acts directly on the bolt rather than loading eccentrically. Bolt failure is outlined in AIC chapter J3. We will focus on J3.6 for bolt shear strength and J3.10 for bearing and tear-out strengths. Let's assume bolt spacing and edge distances are not a concern.
Most often, deformation is an important design consideration, therefore we will utilize J3-6A to account for it. When computing bearing strength, D is the diameter of the bolt and not the hole because the bolt is what is physically bearing on the plate. T is the thickness of the member, and in this case we are doubling it because we have a double angle. And next, we will do tear-out failure.
This part is a bit more tedious as it requires that we recognize the paths that the bolts will likely travel during a tear-out event.
When computing tear-out strength, the clear distance, LC, needs to be computed for each bolt hole. In this case, bolt 3 would tear through the back edge of the angle, whereas bolts 1 and 2 would tear out into the adjacent bolt holes. When doing the calculations, be sure to use the diameter of the hole and not the bolt.
Now we're on a hot roll.
The final piece of this engineering puzzle is going to be bolt shear. This can be found in AIC Table 7-1 and can simply be read straight out of the manual.
So, we will assume the bolt type to be at least Group A, which would include ASTM A325. And the threads will be included in the calculations since we cannot verify if the threads are in the shear plane or not. Finally, in order to obtain our phi PN for bolt limit states, we will create a table with all of our limit states. We will pick the lowest values of phi RN for each bolt and add them together to get our final phi PN. Often, the bolt limit states control, but we shall see.
Alright, so let's compare the phi PN from the tension limit states to the bolt limit states.
The bolts that they are using are adequate. What a relief. Let's party.
Wait, where are you going?